Alrighty. Now, I'm going to share my screen. Unfortunately, I'm going to break a promise. I had promised in my email that there will be no presentation, but I actually found it easier for myself, and I hope for everybody, if we were to focus on what I'm actually going to talk about. So this is a short. I'll finish this presentation as short as possible, and we want to try to get Dave Zader's input on this, because I might be getting this wrong, and if you cannot see my full screen display of the slides, please let me know. Okay, and I suspect you can all see it. In any case, if you want to, I'm going to paste into the chat the URL to this Google slide if you want to download it or view it on your own screen. So this is what this meeting is about, MVP, minimal viable product review for polygon-based planning. So actually this term, MVP, I learned from it actually from Dave Zader. So Dave had mentioned to us that he's interested in scoping out this MVP, a small, cozy sized product that can be used. And so what we wanted to do during this meeting was to discuss what that product might look like. The purpose being to quickly get something which Dave Zader can experiment on. All right, so that's what we're aiming for. And next slide shows, this is the agenda with only 3 items. And again, I hope to get through this as quickly as I can. Hi, Martha. And so the first part of the agenda, which I'm going to launch into, is just a review of what Dave Zader had presented at the ESIP meeting. The second part, so after I present what the needs are, what Dave's needs are as I perceive them, so as I carefully qualify as I perceive them, we will try to get some feedback from Dave Zader. I might have gotten some things wrong, but once we get some feedback from Dave Zader, then I'll like to get to part 2, which is actually just one table. You see the table if you have the link to the presentation. The table lists the needs from part 1 and a first pass as to how those needs can be met by technology or approaches. So one of the technology which we hope to see later today is GeoCollaborate, which is part 3 of the presentation. Right. So let's go to part 1, where I'm going to quickly run through the needs that Dave Zader communicated to us during his presentation about 2 weeks ago. The images that you see on the slides are all images of slides that I took from Dave Zader's presentation, so that we can ultimately trace back the needs to a stakeholder need, right? So we want that level of traceability. We want to trace it back to what Dave Zader said his needs were. And if you, at any point in time, if you need access to any of the supporting materials like Dave Zader slides and all that, click on this link here that you see on the screen. And for Martha, I don't think you saw this URL when you came in, but I've just pasted into a chat box a URL that takes you to the Google slide for this presentation. So if you need to get access to Dave Zader's slides, you can click on this third bullet, which is a wiki page that summarizes the proceedings of our summer workshop, right? And Dave Zader slides can be accessed from there. Now, so without further ado, as a reminder, this is what we all came here to think and talk about, which is reusing data and information across the fire management lifecycle. And I just noticed, by the way, Jessica is from University of California at San Diego, actually, and from the Wi-Fi lab. So thanks, Jessica, for joining us. You may not be on audio yet, but I'm just going to say it anyway.
I'm here, and thank you for having me.
Oh, hey, Jessica. Good that you join us.
Thanks for having me. Cool.
Oh, welcome. And so, if for those of you who remember, our first motivation when we started this off was, look, if you look at the wildfire management lifecycle through these different phases on top here, and we want, there have been a couple of earlier projects where we have examined how data can be traced to decisions, and how do you capture the provenance, the traceability of that data being transformed into decisions, right? So now for this exercise, what we're trying to do is do the same thing, but to see how data information can be captured and repurposed and reused through different phases across the fire lifecycle management. And so by this, we are automatically looking also at how data information can be reused and repurposed by different parties. But parties here meaning, for example, the local, the Boulder Fire Department, and the other party involved would be, for example, Forest Service or even FEMA. So these are different parties that are involved in different parts of the live fire management cycle. Right, so this is what we're after. And here is a snippet from Dave's slide on your lower right-hand side. And one of the focus right now, at least for right now, is we can, using Dave's needs, I think we can focus in on the pre-fire mitigation data information. How are those, how can those be repurposed and reused for during the fire? Because if you look at the lower right-hand side of your screen, where my cursor is hovering over, this is what Dave said. He was recounting in his presentation. And Dave, feel free to jump in and correct me if I'm wrong, because I might be interpreting the slides incorrectly. But Dave had mentioned that what worked in the past was you create a plan up front, but you use the same plan for training, drills, classrooms, and when the actual fire hits, the folks, the incidents crew, the incidents managers who are recruited to fight the fire have all been using that plan earlier for training. And so any data that was referred to in those plans, they have a rough sense already, and there is no last minute panicking and figuring out, hey, what do we do now? So for this purpose, I think Dave Zader's slides 2 weeks ago were really useful in that respect, because it touches on these two different phases, mitigation planning and during fire. And so I think for that purpose, we should continue focus on these two phases for now. Okay, next slide is a couple of assumptions right here. Now, the data, I keep referring to data information because I think at a larger scale, even though we're talking about data right now, but for those of you who have been following what Bill and I have been pushing, the term information is used to encompass publications too, like wildfire science publications. And at some point in time, the work that Gary Burkcross and company are championing in the semantic harmonization cluster, where that cluster is trying to do the hard work of putting together the ontologies of various subdisciplines. Now, that work is very useful for when we need to deal with both looking for data and information. And so I want to keep the information focus here, even though for this little MVP, I think we're mostly focused on data for right now, but let's keep the focus. And my assumption is that, which I think is reasonable, is to say that the data information that you use for planning, you would like to use it for actual fire, and there's a missing word here. The data information sources used for planning and for the actual fire should ideally be identical, right? And I also assume that for peacetime planning, that you have online access to data and information, but when you have active fire management going on, your task force leads, a short form for this that Dave uses is TFLD. The task force leads and the division group supervisors and the folks, generally speaking, kind of the folks on the ground, I assume that it would be best for these guys to have offline access, because you cannot rely on any internet access. And moreover, you are relying on a mobile platform, and you don't have the luxury of multiple screens and a nice keyboard to tap on, right? So that requirement gives us implications for the types of technology that you can use. And so I guess both Jessica and Dave Block, Jessica Block and Dave Zader have been looking at this thing called ATAK, ATAK, which is a platform, a visualization platform. I think used a lot by the Department of Defense community. And later in this talk, we're going to see GeoCollaborate. Dave Jones is going to show us GeoCollaborate, which is used by the FEMA folks, used by National Weather Service, and used by various emergency managers around the country. So we'll get the flavor of GeoCollaborate, how it works. Now, back to this slide, the other assumption is for active fire management. Again, Dave Zader, feel free to push back at some point in time, but I'm assuming that the incident commander, since I think what you had stipulated in one of your plans is you stipulated that the incident commander should be kind of in a fixed place, and by that I assume have access to internet access and electricity and all that. But the task force leads and the group supervisors are out there in the field, and so I assume that the incident commander has a little bit of a more luxury access to the internet and multiple screens and a proper keyboard and all that. Right, so that's my assumption.
It depends on the phase of the fire. During the initial stages of the fire, oftentimes the IC is very much a field going personnel, and they're going to be working out of their truck and trying to run the fire from the front of the cab of their truck. So they may or may not have stable internet. Certainly that becomes, as the fire progresses and they need to make more, they start looking at more of the external forces of the fire, and they've essentially it's their transition points generally like at a type 3 incident, where we know it's going to be extended and we start having more political issues and needs to pass information. The IC tends to take that role, and they'll tend to move to a location where they have access to computers and better communication systems. So that's absolutely true. But the task force and division supervisors, everybody downstream of that's in the operation side is for the most part is always going to have issues with getting data in the field. So one of my thoughts and solutions is essentially what we're doing by creating these polygons is to kind of containerize those pieces of data, and ideally when you got your dispatch, part of your dispatch paperwork is also the data file for all the data that you would need for that polygon and the surrounding polygons around it.
Okay, very cool. And actually, to that point, my next slide actually speaks to that point, because I grabbed this visual from the National Wildfire Coordination Group, where this workflow, it's a very high level generic workflow. I mean, it conceptually makes sense, but I just wanted to paste this diagram here to indicate that at least as far as the NWCG, the National Wildfire Coordination Group is concerned, the thinking, of course, is that there is a place in the workflow. For those who can see my screen, there is a place in the workflow to download offline data and actually edit and create offline data, but ultimately at some point in time to synchronize it back to the master copy held somewhere. But I didn't want to spend too much time on this diagram, except just to mention that this is kind of a natural progression of things, and but of course a lot of ways that you can do this, and we shall not be focusing on how this is done, how this can be done for this presentation. So let me go on to the first need. So I'm going to go down the list here and list the needs. The needs. So what I've done is I've just given them a number, like just a simple ID, N01, N02, and I think I went all the way to N05. But for some of the needs, I broke it down into a little bit more detailed needs, right? So the first need here, and I'll read this off. I don't know if Dave can actually see this. Dave Zader. This need came out of these slides on the right-hand side that you see, these are slides from Dave's presentation, but the need, number one, is polygon identification by identifying 4x4 accessible linear features, right? But what I think we should concentrate on are the more detailed needs. You see them on the screen labeled N01-01, 01-02, and -03. These are one level down. So what I meant to communicate there is, in order to satisfy this need, N01 polygon identification, all right, to identify which are the 4x4, just call it roads for now, but what the 4x4 accessible roads that you can drive vehicles around. In order to do that, right, the first one of the things that you need to do is to first identify the 4x4 accessible linear features from existing databases. Now, there are also linear features that are not in existing databases, but can be extracted and identified from high resolution imagery. And that is what the second sub need N01-02 is about, right? First, of course, try to get from existing databases. If you cannot, it'll be extra nice to have, say, a feature extraction algorithm run on high-res imagery, right? To actually identify and delineate these like one-way roads or dirt roads which are not marked on the map, or even I dare say this because I guess in California you might have this, or actually you have this everywhere, but unauthorized vehicle trails. I wouldn't say unauthorized, it's just vehicle trails that people have used, you know, for some time, and of course folks at the BLM get very mad when you run these unauthorized trails all over their lands, but it happens. But these vehicle trails might be useful in the creation of 4x4 polygons, right? And this need here, N01-03, assuming that you have some idea of the 4x4 accessible linear features, you can use graph theory techniques. Again, we won't go into this here, but if you talk to the folks doing graph theory stuff, graph theory mathematics, they have techniques to make sure that you have polygons that do not intersect, meaning that the polygons just touch each other, but you have no polygons which encompass too many other polygons, that kind of math. Anyway, there are methods to do this. I'm not an expert on this, but it is possible to do it even without thinking about AI and that kind of stuff. So I'm just leaving it there at what you see on the screen. I'm just say identify candidate polygons using graph theory techniques.
So Brian, this is Gary. Just one comment on that. The way I would understand it, and Dave could comment on it, is that he uses both spatial reasoning and essentially domain knowledge to select candidates, as opposed to a mathematical theory.
Dave?
Yeah, I mean, I definitely, I mean, the way I was looking at it is I am definitely looking for the smallest possible perimeter that you can drive around. So that's sort of the definition, and then how we arrive at it, I'm not sure of the, how to make that happen. How do we automate that process? Currently it's all manual, and I had a good discussion with some folks from Lockheed the other day, and they said they've tried to do some of this, looking at how to even map the rail lines, and they've struggled with it. So I'm not sure exactly how hard a problem this is.
Yeah, I would just pick up on one thing about the ability to drive on some of these features. So there's an idea of drivability, which a human sort of has a sense of. We don't necessarily have a measure of it yet, but we might be able to formulate an idea about what that is, like walkability, right?
Yeah, definitely. There's probably some subjectivity to, what is drivable, but I think, we could probably find some way of defining that.
Yeah,
there's a lot of literature on topographic travel cost surfaces that are and one of the things that I would add to this is that instead of looking at imagery as your base using LiDAR for, or high resolution topography kind of gives you a better initial take on like ease of travel in different manners. So if we have LiDAR available for landscapes, this pre-fire planning is typically done with that as being the kind of first round tool.
But Tim, I'd imagine you need if you were to imagine almost like a image processing and algorithm, you might imagine that the algorithm uses actually both image and topography, because in order to eliminate spurious images on the ground that suggest the road, because from the topography you can eliminate these spurious images by saying that the topography is changing too much. For example, the topography is rising at a 50-degree rate, right? 50-degree rate, when the image is suggesting a line that it could be a road. But if it's at a 50-degree rate, it's probably not drivable. So you would use both imagery and topography from a LiDAR to kind of figure out where the roads might be.
Yeah, I also think that, at some point, the ground truthing is important. But if it can remove, the workload of 95% or 90%, that's a great start. And then if we have to do some manual corrections to defining those, that's not, unachievable. But trying to get people to build the framework is like 90% of the battle, I think.
Okay. So surprisingly, we need to move on to, we've got four other needs, but one last comment is actually, surprisingly, I think the feature extraction for using image analysis techniques to identify these candidate roads and all that, I actually don't think it's that hard. I mean, people have done this time and again. I don't want to call it routine, but it's definitely a problem that people have solved. So unfortunately, all right. So let's move on. Second need is identification of tactical opportunities within polygons, and this is where for Dave Zader's needs, thinking through Dave Zader's needs, for example, given that you have identified a polygon where you can drive your vehicles around, but there are certain things within a polygon, for example, water features, bare rock, and other trails in there that can be used to create a fire break. So these are the technical opportunities that Dave Zader often talks about. And so the first sub need from identification of technical opportunities is like identify features. And there's a whole bunch of things here which Dave lists in his slides. Identify features, trails, domestic or wild animal paths, right of ways, fence lines, blah, 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 from existing databases. Again, I put this here because later I'm going to talk a little bit about just the University of Colorado at Boulder, CU Boulder database, which has some of this, at least for Colorado. And of course, for each and every state and each and every jurisdiction, there will be such databases out there too. So let's put this at least on the radar, right? Identify trails and ridge lines and all that from existing databases. But again, like with the previous slide where we talked about dirt roads, which are not in existing databases, again, this becomes a image analysis feature extraction problem where you're trying to use a variety of methods, AI or not, about machine learning or not, to identify features on the landscape that can be part of a technical opportunity. But what I left here speaks to a little bit of what Gary had said. I think where it comes to determining how these other technical opportunities can be combined within a polygon to do fire breaks, that's way too hard for a machine to figure out. And so I put a comment there that this is just best left to the human wetware to go figure this out. But the machine could do take the first pass of doing a feature extraction from images, and even as Tim had pointed out, even from the topography of the land from LiDAR or other means, or even SAR data. Okay. Any quick comments here before I move on to need 3. Okay, so need 3 and 4 are very related. So number 3 is provide geospatial data for planning, training, drills, refreshers, classroom, and operations. Now, this need I clobbered it together partially because Dave Zader in his slides, he mentioned all these planning, training, drills, refreshers, classroom, operations. I think the operations part was not explicitly mentioned, but it was very clear that this was a requirement. So I combined operations and I combined the planning activities and the operation activities into one need. And need number 4 is provide geospatial data for rapid decision making. This is a need that if you look at on my right hand side, this is a need that Dave explicitly mentioned. Provide visual data for rapid decision making, and so by this I interpret that this is more of an operational need. So I don't know if I should have separated it out into a separate need, but I've just done it. So anyway, this was just done this morning. So excuse me if there are some duplicates here. Okay, last need is number 5. This one is we have not discussed this at all. But so here's where it affects thinking about how do you identify and organize the data. So clearly, Dave has in his presentations has presented a lot of different types of data and different attributes. For example, attributes of polygons, attributes of technical opportunities. So there are a lot of attributes and data that Dave has suggested. Now that amount of data and attributes is a bit overwhelming, as I'm sure Gary's team has already been experiencing with semantic harmonization, trying to interview Dave Zader and trying to ask Dave how he thinks about various attributes. Right, it is overwhelming. So I added this need 5, which is essentially to say that given all these needs and attributes, all this data and attributes, how do you in real life manage it in smaller packets such that the person in the field, like the task force lead and the division commanders in the field, are not overwhelmed when they have a tablet in the field. And can you design it such that they have for example, a list of frequently used data, which is grouped into 2 to 5 categories, say, right? But that same 2 to 5 categories, which make sense to a task force lead in the field, may be different from the incident commander in an office-like setting with multiple screens and with laptops. And of course, the incident commander has a different responsibility than the task force lead and would require different kinds of data, right? But again, I put this in here just to put a peg and to think about how do you organize the data by roles or something else such that it is easy for the relevant data to be available with the shortest number of clicks at the right time, right? And so this gets to a question that I would like to put in Dave Jones' head, and this may be applicable for both Dave Zader and Jessica Block when you talk about attack. Like, is there a way for either geo-collaborate or attack to say that you, user X, you play a certain role, and user X is able to configure a favorite set of 2 or 3 sets of data that the user X will always want to have when user X jumps into that role. But if user X switches to a different role, there'll be a different set of data. And so that's something that maybe I'll ask Dave Jones to keep in mind when you do a demo of geo-collaborate, to see if Dave, your other users from NOAA and FEMA have had this need, right, to pre-stage a bunch of data, but that bunch of data may be different if that person or the person switches to a different role. Anyway,
And I think,
Dave?
well, I had a thought, you know, I mean, like, and this, you know, I think this would be a big project, but ideally what we could do if we had all these, you know, different layers of data is, you know, most firefighters want a tool that's going to help them make decisions. So how would, you know, if we could teach the model to make decisions based on all those sets of data. So like, okay, this is the, you know, most likely place to place line. So it would like give recommendations based on all the data that we're providing, how to connect the features to make the shortest line or most, you know, have a couple different categories like shortest line, line most likely to hold, you know, that those sorts of suggestions, so that you're essentially the model is giving the output is giving the, you know, giving them, instead of them having to think through the problem and make the decision with just data, that the model is actually telling them like this is the most likely place where a type 6 engine could possibly drive, so that you could use wet line as your defensible feature rather than having to construct hand line, if that makes sense.
But Dave, so that kind of decision support in the field, I get back to the question of, do you see that kind of decision support happening for somebody in the field with only access to a tablet but no capability to, like, you know, drill down the data, and there's no luxury for the person to drill down the data, or even, you know, so I would imagine like the incident commander, right, back in the comfy, well, I won't say comfy office, but back in a situation where there's multiple screens and a keyboard and mouse and everything, it's easier to imagine that sort of capability for the incident commander. But in the field, so in that scenario that you just painted, do you envision that scenario happening in the field for like a task force lead with no access to multiple screens and mouse and keyboard and all that? Dave, did we lost you?
Oh, sorry that. I was on mute. I think I would envision that occurring off-site, the actual processing of that, and the you know, essentially just being able to send either a shape or a line or a point, you know, those types of, you know, very small data size out to the field, or even you could even communicate that via radio, what that would look like. And so there, I think, you know, as technology increases and we have more access to data in the field, it'll make sharing those types of files more accessible for field going personnel. But you know, but right now it may be something that has to occur on, you know, if you look at the Wi-Fi model, that's exactly what they're doing. They're doing the processing, you know, at UCSD, and then sending us the output of that file rather than us trying to calculate it in the field or even at ICP.
Yep. Okay. So the point here, I think, I think Dave, you're right in saying that, you know, this one requires quite a bit of thinking, because, and that was what I was trying to communicate in that, and this one will be reflected. I tell you what, let me talk about this a little bit later when I show you the table that I've assembled. So the last need, very quickly, is Dave Zader had said one of the needs that he thinks is good to have is the ability to show some of this and share some of this information with the public. To have some of the information public facing to, but that's what I'm interpreting Dave Zader to have said. Having the ability, so what Dave, in case you cannot see this on the screen, what I'm pointing to is, you said having the ability to have some of this information public facing as to perimeter, closest town, subdivision, etc. It is hugely helpful. But I interpreted this to be that you want some of this data to be available to the public. And with that, hang on, we're running out of time. So I would like to flash to this screen and explain myself a little bit regarding the last need that you heard. So what this table is just a quick recap of all the needs from the previous slides. The last need that I identified, provide public access to selected data. Now, I might be misinterpreting this, but I put this here also and listed GeoCollaborate as a potential approach, a potential solution, because I think Dave Jones had mentioned something in Florida along those lines where GeoCollaborate is being considered for use as a public-facing solution for the public to gain some situational awareness of what's happening in the event of a storm surge or flooding happening, that kind of thing. But that's what we don't have time to go through this table. I was hoping to fill out this table a little bit, but we're running short of time. But this table essentially just summarizes the needs identified from the previous slides, some of the potential solutions, or at least initial starting solutions, the approaches that we can use. And so, for example, for some of these needs, the first step that we can do as part of a MVP, a minimum viable product, the first step is, let's go take a look at the National Interagency Fire Center, the NIFC portal, the data there, and also the Wi-Fi, which Jessica Block represents. That they have a data commons, which has been pretty useful. I play around with it to identify relevant data sets. And I won't talk about the Wi-Fi model repository, which is another whole lecture by itself, I guess. I'm not an expert, but here are some potential ways to go about thinking about putting together the pieces that will contribute to a minimum viable product and MVP. But there are some pieces here where GeoCollaborate could play a part, and the pieces where GeoCollaborate could play a part is need 04, provide geospatial data for rapid decision making. But I also identified need 3, where provide geospatial data for planning, training, drills, refreshers, classroom, as a potential thing that GeoCollaborate could fill the role for, because I remember Dave Jones having said that in wargaming exercises with National Weather Service and FEMA and some other bunch of folks, they have used GeoCollaborate in training and wargaming to again do the same kinds of getting people familiar with the kind of existing data that can be used for decision making. I think with that, I want to stop here because we have about 15 minutes left. I don't want to take up all the time, and really I should turn this over to Dave Jones. But any questions before we turn it over to Dave Jones?
This is Jessica. I have a couple of thoughts. This is super cool, and I just love this. So let me just make sure I understand that really the goal here is for understanding how to position resources in the context of these wildfires. And that's what the linear feature extraction is all about. And that's the whole purpose here, right?
Yep.
Okay.
Yeah, that's exactly it, Jess. It's where can we make a stand for holding the fire? How do we get all that on a map so we visualize it rather than having to go out and scout and find it?
Yeah, cool. And so this is totally an excellent use of the Wi-Fi Commons. I'm glad that you guys have started looking at it, and I think this is an awesome idea and project. A couple of things that I see that get in the way all the time are this concept of showing the models in public forums. And I just wanted to plant the seed that I'm working on some ideas right now on ways to visualize the model outputs so that people aren't freaking out about it. Just so that it looks a little bit more generalized, maybe a little bit on fuzzy boundaries or showing directional stuff, and that maybe the way they're visualized to the public and tactically is different. I think a lot of people get stuck there, and I hate that people get stuck there. I think there might be some solutions by just the way we draw the perimeter. And then, and additionally, it's exciting to hear that there are a bunch of data sets that we could possibly access, but it is an interesting machine learning problem to extract the linear features for places that we don't have data, and Wi-Fi has a machine learning group that could potentially help there as well.
Wonderful.
So, and I've done it with some primitive tools, and it's not super easy. And it is just in getting back to the earlier part of the conversation, it is sometimes hard to determine from satellite imagery what is drivable. So there's some challenges there. It's also hard to get access to the high resolution imagery unless you have some sort of government account with Maxar. But we've been working on feature extraction for things like that, and we could potentially help. Anyway, super awesome concepts. Love it.
Yeah, and maybe with this, to transition between what Jessica had said and Dave Strode's demo of GeoCollaborate, one possibility to actually paint a picture of the transition there is after a machine crunches through data pertaining to a current fire, right? You want that crunched data to be served publicly, right? Potentially in a simplified form, or in a different form for the public than that used for decision analysis, for example, as Jessica had pointed out. But it would be great at that point in time to share the data using serve it up through an API, which will allow lots of different platforms to get access to the latest data simultaneously. And so that's where I wanted to let Dave Jones take over at this point in time to show how GeoCollaborate as a platform can actually use data shared by APIs. And Dave's thinking about how FEMA has been using it, National Weather Service has been using it, and so on and so forth. Dave, are you comfortable in taking over now?
Yeah, Brian, that's sure. It's great conversation. And I'll just say hi to everybody. I'll turn on my camera for a moment. Hi, Jessica. It's good to hear your voice again. And that's really good. I was thinking of the modeling aspect as well for, how can you visualize some of this information? And so what we're doing here at Storm Center, and I'm co-chair of the ESIP Federation Disaster Lifecycle Cluster, we're looking at how we can deliver trusted data and information into the hands of decision makers, because there are so many data portals, so many hubs, so many things like that are available, whether the university websites as well. And, the whole concept around GeoCollaborate is to stage data that's important at a certain time to be used by people in a collaborative environment. So I think all of the efforts that are critical regarding machine learning and AI are incredibly important to take what data is coming in and determine, hey, where should we hold this line? Where should we do this activity? And I think until we get to that really trusted AI and machine learning algorithms that can really support decision-making with hardly any uncertainty, that you still need to keep a human in the loop. And with GeoCollaborate, you can keep that human in the loop because they could be turning on and off data layers that are immediately shared across any device in real time. And so Dave Zader's, your presentation at ESIP was great because it really does take a lot of hard work to think about, okay, what are the decision-making pieces of information that we need that don't exist, that we need in geospatial formats that we can pull into this. I call GeoCollaborate a collaborative common operating picture. So I'll turn my camera off, but I did share in the chat a button, a link for everybody to click on. And if you click on that link, you're going to load up a map, and it's going to be the follower for GeoCollaborate. And so essentially what I've done is I've loaded up, let's see. Oops, hold on a sec. I've loaded up a couple of data sets, but GeoCollaborate, you can move around that map, you can zoom in, you can zoom out, but if you turn it on in the upper left-hand corner, and you'll see that go on and off in the upper left-hand corner there, you'll see the switch go on. Then your map will be following my map. And so I'm just going to log in here as the leader, and then you'll have zoomed right into Colorado and Utah. And so if I move the map around, you're going to follow me in real time. And one of the data sets that are on, I turned my camera off. Brian, are you able to see that okay? Are you following me?
Yes, I can. I am following your map.
Yeah. Okay. So I'm just have my second monitor decided to go black on me, but that's okay. What you see are the status of current wildfires that are burning in Colorado. I can zoom out. You can see many more wildfires that are going on. This is a data set that's updated by the Forest Service every day, and it's for the past 7 days where wildfires are burning. But you also see, as I zoom into California, you see some fire, other different fire icons, and you can click on any one of those yourself, right? So I'm clicking at the fire symbol up in Southern Oregon, you know, and what you see are data from NASA, from the FIRMS service, the fire mapping service, showing hotspots from the MODIS sensor on Aqua and Terra. And the other ones are actual fire reports, names of the fire as you click around them. So the whole concept of what Dave is doing, Dave Zader, to put together in a geospatial context various information that is available geospatially, I think it's incredible, because it then makes those data services available for him to share with anybody else at any time across any platform. And so, you know, I was invited to give a presentation to the Tactical Fire Remote Sensing Advisory Committee, which is co-chaired by NASA and the Forest Service, run by Everett Hinckley, actually, who was speaking at the ESIP meeting. And they were talking about all sorts of challenges that they're having. And one of them is, how can you get people on the same platform at the same time, looking at the same data, and then have a subject matter expert really focusing in on areas that you want to focus in on. And so that's one of the things that we're focused on with GeoCollaborate. It's really taking that information that's available via services, could be Jessica's Wi-Fi output for a behavior of a wildfire. You get that output, get some of the machine learning or AI answers that people like Dave Zader need, and then you share those answers out in real time across these platforms. Even if they lose bandwidth connectivity, that data will remain on their device and they can interact with it. Once they connect back again with their connection, then the data updates. So you know, there are other data sets that I could share in here. Maybe I'll just go get one. I'll go get a GOES satellite image, and I'll share that to everybody. So you'll see that satellite image turn on. This image is less than 10 minutes old. It comes directly from the GOES West satellite through NOAA and through the Cooperative Institute for Space Studies at University of Wisconsin in Madison. They're crunching on this data. They're making it into web map tiles all the time. Anybody could take it into any GIS system that they want. You can see the live smoke out west, and the clouds and things like that are also developing. So this whole idea is just about data sharing and collaboration, putting everybody on the same map at the same time, so you can be looking at the same trusted data sets. And I would just love to work with, you know, Wi-Fi. I've spoken with also the folks at Alert Wildfire to get the cameras in here so we can turn them on and off, and turn on particular ones that we're talking about, and they would just turn on for every other collaborator that's using the data. So I'm going to stop there just to create some conversations, but we're working with NOAA, the JPSS program, to really put more NOAA data, satellite data, and algorithms to work, supporting the smoke and fire initiative, or fire and smoke initiative. So we're really at the cusp of taking a lot of advanced science and putting it into people's hands. So they may not know where to get that data, right? They may not know how to manipulate data services, but GeoCollaborate can deliver it to them in real time, and they don't have to know where it is, but they can interact with that data. So, so Brian, I'll take a pause there.
Dave, I have a quick question. So imagine you have the incident commander, the head honcho, right, in a particular situation, and the IC, the incident commander, is briefing a bunch of the TFLDs, the task force leads, in the same room, say, and they are all, the task force leads have tablets, and the incident commander is running this thing on the laptop, and that's fine. I know GeoCollaborate can run on laptops and tablets, but so everybody's following along. The task force leads are following along on the tablets. Now, you said earlier that it doesn't matter if, for example, the tablets lose connection. The task force leads go out into the field, right, and they lose connection. So, and you mentioned earlier that the GeoCollaborate can still run on their tablets with that data.
Yeah, that's right. If they get the data, Brian, before they lose their connectivity, the data will remain on their tablet or their information. So as soon as they come back into a connectivity, that data will then update. So if you have some specific information that you want to deliver, say a geospatial message, you can deliver that through GeoCollaborate. Before they deploy and go offline, they'll have that information on their device.
Wow. Okay. Impressive.
We're also working. Let me just mention, we're also working on this OGC disasters pilot that we were selected for. I think it's primarily supported by Canada and the Peruvian Space Agency and also NASA to really figure out how they can come up with a new standard. Maybe it's GeoPackage or something like that, where critical information can be packaged together securely, and then those packages can be delivered so they work online or offline. So we're part of that OGC disasters pilot right now.
I've got another question, but I think Gary may have a question first.
Sure.
No, I actually don't. I have to actually get onto another call, so apologies.
Oh, okay. But so let me quickly slip in my question. We're actually at the top hour, but okay. So in that last scenario again, the incident commander and task force leads, can the task force leads actually have additional data? Can they have a different set of data that they need, which the incident commander doesn't need? But I mean, I assume that it can somehow have two different sets of data.
Yeah, well, I mean, the idea from my standpoint, and Dave Zader, you can, please, anybody comment and tell me if it's realistic or not. But what we're looking at is, being able to stage data, right? So you have a leader with GeoCollaborate. Let's say it's Dave Zader. He knows, and he's staged all these critical infrastructure data sets that are going to help him fight a wildfire, and so that he has total control as to whether he turns data sets on and off. So if he wants to show ingress and egress roads that a 4x4 firefighting vehicle can take, then he zooms in on the fire and turns that data layer on, and then it turns on for all of the people in the field that need to know about that data set. And then go ahead.
I would agree. That's exactly what we want as far as functionality, because I would hate to restrict data. Like, some people are really high functioning and can process all that, and other people can't, want to turn on one layer at a time. It just depends on how they learn and process information. So I think it's important to give them all the information and let them decide how they're best going to use that data and the tool.
Yeah, because I mean, for me, until AI and ML become perfect, you need a human person in the interface so they can be turning on the right data layers that are critical to that decision making that's being those decisions that need to be made.
Yeah, and I guess when I look at model outputs, I would it's not a cookbook. It's like a suggestion. This is just intel and data to help them make the best possible decision. So it's a decision support tool.
Right, right.
So I'm going to stop the recording here. It's at the top of the hour.